Hello there, friends. We are tackling guided practice 17. This is our polynomial functions of degree greater than 2, right? Which is also known as zeros of polynomials, right? So we've done this for things that have degree 2. So really, this is things that are above degree 2. All right, so we are utilizing that idea that the zeros create factors, okay? So we're going to find the polynomial of degree 3 that has zeros, x equals -5, 2, and 4. And then we're going to find that a value by using that f of 3 equals -24. All right, so we are starting off with our format. So we have degree 3, and I have 3 different zeros. So that means our f of x is going to be equal to some value a, which I will find in a minute, and then times x minus each of those zeros. So x minus -5, x minus 2, and x minus 4. From there, let's clean up that minus the negative. So that's going to be a times x plus 5, x minus 2, and x minus 4. All right, from there, we're going to find that a. So we are going to use that piece of information that f of 3 is -24. So we're going to plug in a -24 for the f of x and a +3 for the x. So that's going to be a times 3 plus 5, 3 minus 2, 3 minus 4. And that's -24 equals a times 8 times 1 times -1. So that's -24 equals -8 times a. Go ahead and divide both sides by that -8. And that will tell you that your a value is 3. And that we're going to plug back in right up here for that a. And that's going to give us a final factorization of x equals 3 times x plus 5, x minus 2, and x minus 4. Okay, and that's our final factorization. Moving on to number 2. Find the polynomial of degree 4 with leading coefficient 1, such that both -4 and 3 are zeros of multiplicity 2, and sketch the graph. Okay, so we know we have to have degree 4. That means I need 4 zeros. They're only giving me 2, but they're telling me that they each have multiplicity 2. So that gives us a total of 4. And our leading coefficient is 1. This is telling us that our a equals 1. So we can go ahead and plug all of that right into our f of x equals our a value is 1. We've got -3 and 4 as our zeros. So x minus -4, but it has multiplicity 2, so it gets a power of 2. And then we have x minus 3. And again, it has multiplicity 2, and so it has power 2. And that's going to give us x plus 4 squared and x minus 3 squared. We go ahead and graph that. And that gives us zeros at -4 and at +3. Now, 4 is the degree, and we know that that's the 1 is positive. So we know it's got to go up at both directions. And typically, this looks like a W when it is degree 4. So it's going to touch that 1, come back up, touch, and come back up, right? When it has even multiplicity, it kind of touches and bounces off as opposed to crossing through. And last one, find the zeros and state the multiplicity. All right, so I see that they both all have a common x cubed. So this is going to become x cubed times 16x squared minus 40x plus 25. This is going to give us x equals 0, and its power is 3, so its multiplicity is 3. So that gives us 3 of the 5. And we're looking for 2 more solutions out of this one. You can go quadratic formula, but I do think this is factorable. Nothing in common factors out, but 16 is a perfect square and 25 is a perfect square. So I'm pretty sure this one gets factored. Square root of 16 would be 4. Square root of 25 would be 5. And then to make it negative in the middle, we would need them both to be minus. This tells us that we're going to get, set this equal to 0. X equals, add your 5, divide by 4. And it shows up twice, so it has multiplicity 2. Okay. So our complete factorization then is going to involve. Now, let's see. When we factored it, there was no number that we pulled to the front. So that means our A is just 1. And so we're taking this part and this factorization here. So that's x cubed times 4x minus 5, and that shows up twice. So that's our complete factorization. And then a quick sketch of the graph. So we've got a 0 at 0, and that one has an odd degree. So we're going to cross through that one. And then that 5/4, that's 1 1/4. So that's going to be about here. And that one has an even degree, so we're going to pop off of that one. Now, if you were to plug a big number into that, the A here is positive, so it's going to go to positive infinity as you go to the right. Okay. Now, this is an odd degree. It's degree 5. That means it's going to go the opposite way on the other side. So if it's going up to infinity on the right, it's going down to infinity on the left. And we're going to come and we're going to pass through the one with degree 3. We're going to bounce off the one with degree 2 and go up and touch.